Well, hello. I'm videotaping today for my favorite time of the day, and we're going to work on two-step equation word problems. So I've got this video starting on your table of contents. I haven't shown it in a while. We are on our fourth unit from Algebra Standard 7, Objectives 1 through 3, 7th grade, third standard, Objectives 1 through 3. Our page 33 was our one-step equations, 34 was our operations vocabulary, 35, we did the two-step equations, and we are now going to be on page 36, and we're going to practice writing two-step equations. So make sure you have your table of contents updated, and I'm going to turn to this page 36. You will start with a strip of questions like this. Questions 1, 2, and 3 are just the computation problem worked out exactly as you would read it. Problems 4, 5, and 6 are actual real-life word problems. So when you cut them each separately, put problems 1, 2, and 3 across the top. Leave yourself plenty of room to write and solve the problem. And then in the middle of your page, you're going to do problems 4, 5, and 6, again, leaving space at the bottom to work them out. Let's work these together. So pause the video, prep the page, and come back when you're ready. Okay, so problem number 1 reads, 109 equals the product of 5 and a number plus -1. So this is going to be filled with terms that you might want to turn to your operations page to know, like the word product. Product means the answer to what type of problem? Yes, multiplication. So if I go and I read problem number 1, I'm going to read left to right and write them down as I go. 109 equals, and then I'm going to read the term together, the product of 5 and a number. Well, if product means the answer to multiplication, and of also means to multiply, then 5 and a number is 5 times a number. Now, when we have a number next to a variable, that automatically means multiplication, so I do not need to put a dot between them or separate with parentheses or anything else. Then it says plus -1. Now this is awkward. In algebra, we would not have two signs right together. So you could decide to rewrite the problem, and when you have a positive times a negative, it would be negative, correct? So -1. Adding -1 is the same as subtracting 1. You could write it like this and simply say, oh, I know to add 1 to both sides. Or you could look at it this way and know, yes, I would add 1 to both sides to begin. And that's what I've done here. I've started with drawing my line down, the equal sign, and dropping my equal sign, and a total line. Then box in the side of the equation with the variable, circle the variable with its multiply and divide partner and bring it down for later, then get rid of what's left in the box. -1 is here, so I'm going to add 1. When I do it to the other side, I get 110 because 109 plus 1 is 110. Now, the number with my variable is 5. It's being multiplied, so I'm going to do the inverse and divide. When I do to one side, I do to the other. So now I've got n by itself. N is equal, and then 110 divided by 5. You may use your blue calculators. 110 divided by 5 is 22. I had no problems really with integers on this question, so that was nice. Question number 2. 4 is the same as, so that means 4 is equal to the quotient of m and 7. Quotient, I could look it up and know that that means a division problem, and it reads m and 7, so from top to bottom, that's the order I'm going to write it. The quotient of m and 7 less 54. Now, I know sometimes there's a question of if I switch the order. It doesn't matter with addition, but it does matter with subtraction. So you might want to double check the term less. And when I do that, less just means to subtract. But if it said less than, then I need to switch the order. This just said less, not less than. So I can write it from left to right. Draw the line down my equal sign. Bring it down. I like to bring it down twice. Draw my total line. Find my variable and box in the side with it. I'm going to circle and bring down the variable and its multiplier divide partner. Now I'm ready to start my inverse operations. All of that is set up. To solve, I'm going to do the opposite of minus 54 and add 54 to both sides. Crosses out here, so I have only m over 7 to bring down. Bring down my equals. 4 plus 54 is 58. Now I still want to get m by itself. 7 is with m and it's being divided. So the inverse is multiply by 7 on both sides. So now I have m to come down, bring down my equal sign, and 7 times 58, again, 58 times 7, no integers to worry about. My answer is 406. Okay, we're ready for the third problem. Third problem, 325 is 172 less than, so I know I'm going to need to do a reverse there, the quotient of, that's another divide, n and 2. A lot going on here. First, I'm going to write it the way I read it, left to right. 325 is 172 less than, so I'm going to be flipping that over. The quotient of, so that means a divide problem, n and 2. Okay, so now I want to rewrite that before I solve it. The n over 2 needs to move to the front, then subtract 172. I'm going to draw my line down the equal sign and drop it twice. I'm going to box the side of the expression that has the variable and bring it and its multiply and divide partner down. Now I need to get rid of minus 172. I'm going to add 172 to both sides. Now I have my n divided by 2, my equals, and 497. I still need to get n by itself, so it's being divided by 2. So I'm going to multiply by 2 on both sides. Using my calculator, 497 times 2 is 994. Okay. So, those were not necessarily easy. If you followed me, you did a really good job. We used product and knew that was multiply, quotient meant divide, and we did a practice with our less than. Let's look at our real world situation questions. Let's read the entire question and then write an equation to represent it. A plumber charges $88.50 per hour. Woo! They make a lot more money than a teacher to complete a job. He or she also charges an additional flat fee of $35 for each job. That's very common with professionals that do labor because they want to make it worth their while to use their gas and their time to come out to the house to even look at the situation. The total charge, that's going to be our equals then, for one job was $256.25. That looks like a good place to start. So problem number 4. I know the job equals $256.25. He charges $88.50 an hour. So 88.5, I don't need that 0 there. An hour, that means per hour, okay? Per hour. So I know that per sometimes is divide, if I am driving 50 miles per hour, but it can also mean to multiply for each hour worked. So here, he's saying for each hour he works, he charges $88.50. On top of that, we're going to add the $35 fee. All right, I think we're ready to solve this. $88.50 an hour plus $35 to come out and look at the job, and this time the bill was $256.25. Let's draw a line down the equal sign and bring it down, and a total line. I'm going to box the expression that has my variable, and I'm going to bring down my variable and its multiply and divide partner. So $88.50 an hour. I still need to get rid of this plus 35, so I'm going to subtract 35. Be careful to not line up the 35 underneath the 25. This is 35 whole dollars, like 35 decimal 00, if that helps. And don't forget to put your symbol. If I'm subtracting it on the left, I need to subtract it on the right. So now, $256.25. Watch carefully when you put it into the calculator. The decimal is super tiny, hard to see. You need to be sure that you're getting it correctly. Minus 35. My answer, $221.25. Now, I still need to get H by itself. So I'm going to bring down my equal sign. And here I have a multiplication step, so I need to divide. I'm going to divide by 88.5, so I need to do it over here as well. And I've got a problem ready to go. I can bring my H down, bring down my equal sign, 221.25, which is still in my calculator, divided by 88.50 is, and that would make sense, 2.5 what? The H stands for hours. So for 2.5 hours worth of work, he charged over $250. Plumbers are expensive. That is actually very realistic. Okay, let's look at the next problem, problem number 5. This is something you're a little bit more familiar with, I bet. A carnival. A carnival charges $5 to enter and then $2 per ride. If you paid a total of $23, how many rides will you get to have? Well, let's start off. Problem number 5. I'm going to start by paying $5 to enter. I'm not going to subtract the cost of my rides. I'm going to add that. I'm going to add that $2 per ride. Is that divided by rides or times the number of rides? Correct. It's times the number of rides. And all together, I paid a total, even though it says of, that's not multiplication, because it said a total of $23. This one will be simple to solve. Draw a line down my equal sign and drop it on my total line. Box in the expression, circle and bring down my variable with its multiply and divide partner. Still need to get rid of this positive 5, so I will subtract 5 from both sides. 23 minus 5 is 18. If it's $2 a ride and I spent $18 on rides, yep, this is being multiplied, so I'm going to divide. So the number of rides I had was 18 divided by 2, or 9 rides. Very good. And our last question, number 6. I am anticipating that this problem is much more like what you'll do. If you do a problem like this, they very likely will give you the written expression and ask you to solve it. But you should be able to write one like this. Let's look at problem number 6. A book has 150 pages and you read 3 pages per day. After a certain number of days, there are 60 pages left. What equation represents the day, D, when there are 60 pages left? Well, you have 150 pages, and as you read those pages, they become less, correct? To where in the end, you only have 60 pages left. So, I'm going to subtract the 3 pages per day. I'm starting with 150, and then as I read them, I'm eliminating the number of pages I have left to read are going down, so that's why I'm subtracting. How are we going to write 3 pages a day? Think about it. For each day you're reading, you need to read 3 less. So, 3 pages a day. Even though I'm using the word per, here again, it's being used to multiply. So, bring down my equal sign and draw a total line. Box the expression and bring down the variable and its multiply and divide partner. Be sure to include the symbol in front because now this is a -3 a day. I still have the 150 to get rid of, so it's a positive 150, so I'm going to subtract 150 from both sides. Here, signs are different. This is a positive 60 and a negative 150. So if you're still using your integer cheat card, you would look here and say, when I'm adding and I have different signs, I have a negative 150 or a minus 150 and a positive 60. So my signs are different. I need to subtract my numbers and keep the sign of the bigger number. So 150 minus 60 is 90. Be sure you remember to keep the sign of the bigger number. There were more negatives, so my answer is negative. Now, I still need to solve for D. So, -3 is being multiplied to my D. So, the undo multiplication, I'm going to divide by -3 on both sides. D equals, what's 90 divided by 3? But 30. And a negative divided by a negative. Let's look. When multiplying and dividing, same signs, 2 negatives, going to be positive. So, does it make sense after 30 days? To go back and plug it in, let's check. If I started with 150 and I subtract 3 times D of 30, would that equal 60? Well, let's multiply 3 times 30 and get 90. 150 minus 90 is 60. So that is the correct answer. And you would have positive number of days. Took 30 days. And you can be precise and write days under your answer there. Okay, so there are 6 problems that we've worked on your 2-step word problem page. 3 we wrote from a description and 3 real-life situation word problems. Okay.